Hey everyone, today I'm going to talk about the espinoreticular fibers. And these fibers will ascend within the lateral funiculus. We have three funiculus. We have the anterior, lateral, and posterior. And the lateral, it will ascend within the lateral funiculus of the spinal cord. And they do not form a separate pathway. We can say that they are much more intermingled with the spinothalamic fibers. These fibers will terminate on the nuclei of the reticular formation in the brainstem, and the reticular formation, you probably know, is a network of interconnected neurons, and these neurons will be located deep within the brainstem, and they will be important. They will have important roles in arousal, attention, and also sensory processing. And the espinoreticular fibers are mainly involved in transmitting burning pain, which is a type of neuropathic pain characterized by a persistent, intense, and quite often localized sensation of burning or tingling. And this function will highlight the role of these fibers in nociceptive pain signaling. And there are some clinical information that I would like to mention, but first let me just complete this illustration. As you can see, here is the spinal cord. Okay. Here's the spinal cord. Gray matter with the anterior posterior lateral horn. Here's the lateral spinothalamic tract. Okay. And here we have the espinoreticular fibers. Espinoreticular fibers. Okay, all the way down here. And here we have espinoreticular fibers ascending. Okay. Let me just write this down. Espinoreticular fibers also espinoreticular fibers. And here is the lateral spinothalamic tract. Spinothalamic tract. Okay, so this is the main structure of this lecture. Let me just this is just separate the midline. I believe that it's important to mention some clinical information related with pain processing. Okay, so espinoreticular fibers, they will contribute to modulation of pain signals, as I mentioned before, and it will relay information about painful stimuli from the periphery, okay, via the spinothalamic tract to higher brain centers via this reticular formation. This pathway, guys, will be particularly important for processing chronic neuropathic pain conditions. Neuropathic pain, which espinoreticular fibers help mediate, can result from nerve damage or dysfunction. And conditions such as diabetic neuropathy, postherpetic neuralgia, or phantom limb pain usually involve altered activity in these pathways. And usually disruptions in the espinoreticular pathway can also lead to abnormal pain perception and sometimes even hyperalgesia. For example, in lesions in the lateral funiculus or reticular formation can alter pain transmission, and this will lead to either heightened pain sensations or loss of pain sensation perception. It's important to understand the espinoreticular pathway, especially to develop treatments for chronic pain. And there are interventions that modulates activity in this pathway. Some we can include here, you probably know very well, pharmacological agents, usually targeting specific neurotransmitters or neuromodulation techniques that eventually could provide relief to patients suffering from neuropathic pain. The lateral funiculus. The lateral funiculus, just to remind you, is one of the three major divisions of the white matter in the spinal cord. And it will contain ascending and descending tracts, including this one, spinothalamic tract and the espinoreticular fibers. And the reticular formation here, as you can see, is a complex network of neurons that extend through the brainstem, and they will play a critical role in regulating arousal, sleep-wake cycles, and sensory integration. I already mentioned this, but its involvement in pain processing. It's important in both physiological and pathological states. When damaged, the spinal cord, for example, damage the lateral funiculus, especially where the espinoreticular fibers travel, this can disrupt the pain signaling. And depending on the location and the extent of the injury, this results in either loss of pain sensation or also exaggerated pain response. Brainstem lesions, injuries or disease that usually affect the reticular formation, can impair pain modulation. And certain neurological disorders or strokes involving the brainstem may alter pain perception, which contributes to chronic pain syndromes. And yeah, this is pretty much what I have for you guys. Just to wrap up, espinoreticular fibers are integral components of the ascending pain pathway, and that will travel alongside the spinothalamic fibers in the lateral funiculus of the spinal cord, and they terminate in the reticular formation of the brainstem. There, they will play an important role in processing and modulating burning pain. And clinically, especially if you are a physician or even a physio, if you understand these fibers, it will help you to provide a proper diagnosis or even suggest treatment for this, to relieve to this condition, to relieve the anything that might affecting these fibers. Um, yeah, and I hope this lecture is clear. If you have any question, please drop a message below, and we'll see you next time for another lecture. Okay? Cheers.